All right. I'm Ravi Murthy. I work at Facebook. So I'll be talking about something that's quite different from the sort of the scientific applications that we've been hearing throughout the day. So switching gears, I'm going to be talking about the analytics infrastructure at Facebook, touching on a few highlights of the systems we've built over the past few years, but specifically focusing around the thought process of how we go about choosing sort of the raw material for building these projects. When you look at Facebook of today, it's basically this global distributed massive service accessed by a lot of people around the world. They access it through a variety of browsers, tablets, mobile devices, and they share a lot of content on a daily basis. They upload a lot of photos, and ultimately this makes into when you go to a site, you see a page like this, but when you look at a page like this, it's actually multiple products that have all come together to provide this experience. There's what we call the social graph. This is the information about users, friends, relationships, and this is stored in a heavily sharded MySQL database. And there's a talk tomorrow that will go into sort of the details of this transactional infrastructure. There is the photos product that's stored in a specialized blob storage. We've got our Messenger, a chat product that makes use of HBase. But the thing for all of these things is each of these is a very specialized product with a very specialized need in terms of the read-write patterns and the scales and so on. And so there's a specialized transactional infrastructure for each of these things. But behind all of these successful products, what is common is that they're all data-driven. So behind each of these successful products, there's a lot of deep analysis of data that happens. And that's sort of the focus of my team on the analytics infrastructure. So just to give a few examples of what I mean by data-driven products. When you think about data, yes, it's used for doing things like ads targeting, sure. But it goes way beyond that. When you go to the news feed, the exact set of content that you see in terms of the posts and the ordering of these things is driven by a deep analysis of data, machine learning models, stuff like that, recommendations, pages you may like, people you may know, things in graph search, finding restaurants to go to. There's a lot of bad actors, spam in the system. How do you keep the integrity of Facebook experience? A lot of, again, deep analysis of data. There's one thing that I want to spend a little bit more time on, and this is this notion of A/B testing. Fundamentally, at Facebook, we've got this philosophy called move fast. And what move fast is the idea that you constantly iterate and measure and improve your products through iteration. And on any given day, there's literally thousands of experiments that are being run on the site. So if you go to Facebook, you will see a slightly different version than someone else. And the thing that really makes this massive A/B testing thing work without descending into sort of chaos is this experimentation framework. And what you see here is sort of a screenshot of the impact of one experiment on dozens of different metrics. So this is giving the analysis to the product engineers that this particular experiment, this change, it could be something simple like a change in the color of a button all the way through big features. What is the impact of that across all the other key metrics? So this is sort of a core experimentation framework, and a lot of the underlying analytics infrastructure is used to drive this. So just to give a sense of what our development philosophy is, it's this move fast. And what is move fast? It's iterative development. You know upfront that you don't know all the requirements, so the requirements do keep changing. And things do keep breaking. We're constantly pushing the systems to the limit of what it's capable of doing. So what that means is when we look at a software stack, the sort of the must-haves is we got to have access to the source code, and we have to have deep in-house expertise in these systems. And so once you think about that, sort of the traditional off-the-shelf, commercial, proprietary, closed source systems are basically a no-go. it's not going to get off the ground because of these sort of requirements. So with that sort of context, let me go into a little bit of details of what the analytics infrastructure and the underlying data warehouse actually looks like. So imagine you've got a user coming into facebook.com, adds a friend, tags a photo. So there's a transactional path to this action, goes into MySQL. But then in addition to that, there are log records that get generated. And all the log records captured by all of these front-end servers get transported through a system called Scribe and reach a central log storage in a matter of seconds. And then there is a periodic process that goes and loads it into our central data warehouse. In addition to that, there is also periodic jobs that take all the data from the MySQL databases and load that into the warehouse as well. So in about a few hours, all of the data ends up there. Just to give a sense of what the scale of what I'm talking about here, on any given day, around 600 terabytes, and these are sort of public figures as of a few months back, 600 terabytes a day, new data ending up in the warehouse. On any given day, we process 10 petabytes of data. And when you look at this total size of this warehouse in the aggregate, at this point, it's about 250 petabytes. And it's growing. It's growing rapidly. And at this pace, at some point soon, we'll reach an exabyte. So it's truly Exa-Scale system. So what is underneath all of this thing? There's a core analytics stack at the very bottom. The reliable, scalable storage system that we use is a derivative of the HDFS, the Hadoop Distributed File System, on top of which we've got the MapReduce layer that distributes computation. And on top of that, we've got a system called Hive, which translates SQL queries into these MapReduce jobs. So this is sort of the core batch analytics stack that a lot of the analysis that I talked about before runs on. A couple of examples of what these pipelines do on top of this stack. One is an example from the ads world, where we have a pipeline that takes all the impressions that ads delivers, the clicks and the user information, and transforms it into features that go into a machine learning model. Another example from search space, we take all the content from the social graph, add in all the user content, transform it into the graph search index. So this stack is great in terms of the reliability and the aggregate throughput that we get out of it. But what we have seen is, again, each of these projects had a history where either we take the open source project or we contribute back to open source. But in each of these cases, there's been a whole lot of enhancements to it that were needed due to the scale and the reliability needs of the Facebook systems. And there's a good, at this point, a symbiosis between the work that we do inside of Facebook and open source community, where changes are sort of flowing in both directions. And the list that I won't go into here are sort of examples of things we've done at each of these layers, in the HDFS layer, the MapReduce, and Hive. There are things that are many years, several years ahead of where the rest of the industry and the rest of the community is at in terms of the problems and the scalability limits. So we just go ahead and make these changes. We make them on the open source project, put it back in open source. But ultimately, it's all driven by the move fast and enable products to move fast. But a couple of years back, what we discovered was, yes, the MapReduce Hadoop stack is great for sort of batch analytics. It's great for throughput. But there are many other important use cases that the product engineers, the analysts, the data scientists inside of the company needed. So I'll briefly touch on a few of these use cases. One is around the latency of data. So Hadoop, great for sort of batch processing, but many times you really need access to the data as it happens in real time. So we built a bunch of stream processing real-time systems to address those use cases. In other cases, we had need for interactivity, where analysts need to sit down and interact with data in a much more low latency kind of an environment. They want fast answers. And then there are yet another case where we want to be able to do iterative graph-style processing. So I'll talk about what we did specifically for the last two use cases. So for fast answers, again, the motivation is very simple. We've got a bunch of people inside of the company who look at data, and their productivity and effectiveness at their job is basically limited by how many queries can I run in a day. If I can run more queries during a day, then I will be better at my job in terms of getting insights, understanding the trends. If the answers come back quickly, I'm going to be more effective as well. And it turns out that in many of these cases, they don't really care about the 100% accurate results. Getting sort of 95% approximate results are OK, which opens up a whole new dimension of design trade-offs. So what we did over the last year is to build out a new system called Presto, which again operates on the same underlying HDFS, the 250 petabyte scale warehouse, but it's a brand new distributed SQL query engine. And at this point, just to give a little bit of history on that, when we started about a year back on this particular use case, we looked at what was out there in open source, and there's nothing really that fit the bill. Either there's just not reliable, not scalable, nothing that sort of fit the requirements that we had. So we had a small team of 4 people starting off about a year back. We built up the system. It's been running in production within Facebook for more than 6 months now. And it's production grade. We'll release it in open source soon. So this is sort of a very similar life cycle to how the Hive project kind of happened probably about 4 years back. The other use case is around graph analytics. The difference here is it's a lot of processing that fundamentally doesn't fit into the MapReduce style paradigm. And a couple of examples there. We've got the social graph. That's the graph of all users and friends. We've got this thing called the open graph, which also adds in user actions, like if I like a movie or I went to a restaurant, that all makes up into this open graph. And we want to be able to do things like clustering this large-scale graph into things that are similar to each other. We want to be able to do things like PageRank on this large graph. And when we wanted to look at systems that could help us do it, there was nothing that really could fit the bill. And again, over the last year, we've built out a platform based on Giraph, which is an Apache open source project. And it's a sort of a similar life cycle about a year back. We looked at the open source project. So here, there was actually something that could function as a good starting point. So we started off with Giraph, but then made tons of changes over the last year, lots of improvements to scale it, make it more reliable, make it more efficient, to the point where it's now meeting all the needs that we have internally. And all of these changes are back out in open source as well. And the latest result, if people are interested, on our blog, we talked about how we scaled it to a 1 trillion edge graph. So that's pretty cool. So just to sort of summarize, when I kind of look at how we work with open source projects and how our needs and requirements are sort of unique, I talked about move fast, and that's more than just a philosophy. The 2 projects that I mentioned show that small teams of people over 6 months, year, building out sort of large-scale systems. The scale is obviously, again, unique. There aren't that many places out there that need that level of scale. So we are constantly hitting the limits of what's out there, and we have to innovate and build out new things. The other aspect of it is whatever we build has to be integrated into the rest of the Facebook ecosystem, whether it be how we do monitoring, how we do alerting on anomalies, how we do provisioning, deployment. There's a whole life cycle of a software project. It has to be deeply integrated into it. And ultimately, we have this notion of we have to be able to customize everything. And when I mean by everything, it's literally all the way from the way we design data centers, the way we design hardware, server systems, network, all the way through the stack. And when we're looking at that scale, small improvements can make a big difference. And when you're looking at customizing hardware and network, the obvious question is, like, why stop there? I mean, obviously, we will want to customize the software exactly the way we want it, and that opens up huge value and huge impact to the business as a whole. So that's my thoughts on Facebook infrastructure and how it relates to sort of the buy versus build decision. Thanks.